Hello everyone, my name is Samruti Mohan Patil, roll number 525 from FICSC Division E. Today I am going to give short presentation on the topic Geiger-Müller counter, which is a part of our subject engineering physics. This instrument is very important in nuclear physics because it helps us detect radioactive radiation like alpha, beta and gamma rays. This device was invented by Hans Geiger and Walter Muller in 1928. Geiger and earlier created an alpha particle detector in 1908, but after teaming with Muller, they improved it and made a counter that can detect multiple types of radiation. Today, GM counters are widely used in laboratories, hospitals, nuclear plants, and research centers. Now let's look at the construction of the GM counter. It mainly has four important parts: metal cylinder, cathode. The outer body is a hollow metal cylinder. This acts as a cathode, thin tungsten wire. At the center there is a very thin tungsten wire stretched along the length of the tube. This wire works as the anode. Mica window. At one end of the cylinder there is a thin mica window. Radiation enters the tube through this window. Gas inside the tube is filled with argon gas or any inert gas. This gas plays a major role in the ionization process. A high voltage is maintained between the anode and cathode, and the anode is connected through resistance. So overall the GM tube is sealed metal cylinder with a central wire and gas inside. Now let's understand how the GM counter works. When a radiation particle enters through the mica window, it hits the argon gas atoms. The entry of the radiation ionizes the gas atoms, meaning electrons and positive ions are formed. Because of the high voltage, these electrons move very fast and collide with other atoms, causing more ionization. This chain reaction is called the avalanche effect. The sudden ionization produces a current pulse. Although the pulse is very small, around 10 microvolts, it is amplified by an electronic amplifier to a detectable level. Each radiation particle produces one pulse. The counter counts these pulses, and that count tells us the intensity of radiation. So one particle is equals to one pulse is equals to one count. The GM counter has many applications. Detects nuclear radiation alpha, beta, gamma used in cosmic ray studies. It is lightweight and portable, so easy to carry. Used to mineral prospecting to find radioactive ores. Helpful in labs and hospitals for safety mentoring. But along with advantages, there are also some limitations. It has a large dead time, meaning after detecting one particle, it cannot detect the next particle immediately. It cannot detect neutrons. It has low efficiency for detecting gamma radiation. It gives only the count, not the energy of the radiation. This is all about the Geiger-Müller counter. Thank you.